My name is Zach Moore, and this is project number 2 for Physics 2010 online, and I will be presenting convection, conduction, and radiation. Heat. 3 things we should know about heat is, first, that heat is necessary for life. Without heat, we would all simply freeze to death. And 2, that coldness is simply the absence of heat. Just like darkness is the absence of light, there's no such thing as darkness. Coldness is simply the absence of heat. So there's no such thing as coldness. We're only cold when there isn't the right amount of heat that we would need to be comfortable. And that also heat is transferred in 3 main ways: convection, conduction, and radiation. These are the 3 main ways in which energy is transferred from molecule to molecule. First, I want to present convection. Convection is simply the transfer of heat by the actual movement of warmed matter. And this form of heat transfer usually occurs mostly through fluids, which is gases or liquids. And then in the picture here, you see the process of convection going on. You see the circular motion. That is typical of convection, and you see that the hot and less dense water in the pot is rising to the top, and the water cools and becomes more dense, and that's at the top, and it sinks to the bottom, and it goes in that circular motion. That's simply how convection works. Another example of convection. Convection plays a role in how the Earth's weather system works. We've all seen on the weather when we watch the news how cold fronts and warm fronts will be moving in from place to place, as they say, and oftentimes when these fronts hit each other, that's when storms occur. Here is the convection process of the air, which affects our weather. And again, you see the circular motion and see that the cooler, denser air is going down to the bottom of the surface, and then the warm, lighter air rises, and as it goes in that circular motion, it just continues to work in that fashion. Next is conduction. Conduction is the transfer of energy through matter from particle to particle. This means that in conduction, things must actually touch. This form of heat transfer is the way heat is transferred through solids. Convection doesn't work through solids very well. It can. For one instance, convection can work in sand, which is a solid, but most solids it doesn't work, and conduction is used to transfer heat through solids. As you see in the picture, the match is on one end of some kind of rod, and that's of course going to be the hotter end, but as the rod gets warmer, that heat will travel through conduction out the rod, and then if someone was to touch it on the other end, say it was a metal rod, it could be very hot, but you could definitely feel the heat off of the flame either way. Here's a couple examples of conduction. Why does metal sometimes feel cold? The answer to that is because of conduction. In actuality, the metal is really not that cold, but when we touch the metal with our hand, because we're solid and the metal is solid, heat from our hand is transferred out into the metal, and therefore we recognize that as the metal is cold. But in all actuality, it's really not. And then another example would be cooking with a metal pot. This uses conduction. Say you set a metal pot on the stove eye, which is a solid, and it's heated up. Once you set the pot on the stove, the bottom of the pot begins to heat up through conduction from the stove eye, and then it raises on throughout the pot all the way up the sides. And if you have a metal handle, into the metal handle, it could also get very hot, and you would have to use something to pick it up. Many pots have either a wooden or rubber handle, and this is because they are poor conductors compared to metal. Therefore, the heat won't travel through the wood or the rubber as it would through the metal, so the handle doesn't get as hot, and you can still pick it up. But even still, it will travel somewhat up the handle, and you'll be able to feel it. Within the pot, conduction actually even goes to the water molecules that are within the pot on the outsides of it, and it conducts into the water, which starts a convection process within the water, and you will begin to see the change. You'll begin to see the change in the exchange of water with the cold water going to the bottom and the hot water going to the top in that circular motion that we seen earlier. And the next thing I want to look at is radiation. And radiation is electromagnetic waves that carry heat energy through space. And there's many examples of radiation, but the largest heat provider for our planet is the sun, and it uses radiation. As you see in this picture, the sun emits a large spectrum of sunlight or rays to the earth, and that goes all the way from gamma rays all the way down to radio waves. The sun produces all of those, and we get all of those, but mostly what actually hits the earth is everything in between UV rays and infrared rays is what we absorb most on our planet. Once these rays of radiation hit the planet, some of them are absorbed in our atmosphere, and some of them are used to heat our Earth's surface, and then even some of them are re-emitted back out into outer space. And so the difference, the reason that the sun would have to use radiation is because in outer space there's no air, or there's no gases, there's no liquids in order for convection to work. And also there's no big metal spoon that reaches from the sun all the way to the earth for conduction to work. Therefore, anything that radiates has to be able to not use a medium. It has to radiate through a vacuum, and that's how radiation works. That's how the sun's rays reaches the earth. And another example of radiation, radiation can be seen as well when cooking with a metal pot on a stove. You can see all three ways being used right here. The water within the pot is using convection, and then the pot itself is conducting heat from the stove eye, and then the flame at the bottom, the heat that's not being used by the pot is radiating away from the flame, and the area around it can be heated that way. In all three forms of heat transfer, remember this: the heat travels from an area of high temperature to an area of low temperature, which means heat travels on a gradient and it wants to reach equilibrium. And so that's something that you can always remember dealing with any form of heat transfer. And here is my works cited. Those are the websites I use to gain the information. Thank you.